Algebra 2, this is section 4.8. This is the last section of the chapter that we're going to do. I think there might be a section 4.9, but we're skipping it. But section 4.8 is kind of a fun section. It's a shortcut, kind of, to the long division and synthetic division. So we're kind of going back to that. But very, very easy section. It's linked with long and synthetic division. So let me start out by doing an example and showing you the long and synthetic division. So up here it says synthetic division can be used to find the value of a function. Consider the polynomial function negative 3x squared plus 5x plus 4. Okay, and we're going to take that thing and we're going to divide by x minus 3. Okay, so we've done that same problem using long division and that same problem using synthetic division. So here's what we've got going on here. We're dividing by x minus 3, and then I put the inside here, negative 3x squared plus 5x plus 4. So what we do is we ask ourselves, what can we multiply by x to get negative 3x squared, and it's negative 3x. This is kind of shifted over a little bit. Usually I put it right over top of where it's at, but this is just how the book did it. So, and then you multiply back through. So negative 3x times x is negative 3x squared, and negative 3x times negative 3 is positive 9x, okay? Then what you do is you flip the signs. So you that one changes to plus and that one changes to minus, and then you add. So the 3x squareds are going to go away. 5x minus 9x is negative 4x, and then I drop the 4 down. Okay, and then I continue and do it one more time, and I say, what can you multiply together, or what can you multiply by x to get negative 4x? And that's negative 4. So negative 4 times x is negative 4x. And negative 4 times negative 3 is positive 12. And then I flip my symbols again, okay? And the 4x's should cancel out. And 4 and negative 12 should give me negative 8. Okay, now negative 8 is my remainder. So when I go to write this as my answer, the answer is negative 3x minus 4 minus 8 over x minus 3. That's how I'll write my entire answer, okay, for my long division. But the important thing to note here is that negative 8 is the remainder, all right? For synthetic division, I'll go through kind of how they got this. So again, with synthetic division, rather than putting minus 3 on the outside number here, it's actually plus 3 because you set x minus 3 equal to 0. So x actually equals a positive 3. So that 3 is the number that goes in the box on the outside. And then you look at your coefficients out in front of each one of these, and those are your numbers that go here, okay? So negative 3, 5, and 4. Negative 3, 5, and 4, okay? The first number you're going to drop down so that negative 3 just stays the same. Then I take 3 times negative 3, and that makes negative 9. And then I add. I don't flip my symbols like I did over here. I just add. 5 minus 9 is negative 4, and then I multiply again. 3 times negative 4 is negative 12, and then I add again, okay? And I always put this last number in a box. They kind of did that also, okay? So then when I write my answer, it's negative 3x minus 4 minus 8 over x minus 3, which is exactly what I have over here. Okay, we're taking and doing the same thing, but one is long division and one is synthetic division. Now, for both of those, I got the same answer, which I should, and the remainder for each one of those was negative 8, okay? Now, that remainder, this whole section is talking about that remainder, okay? And there's a shortcut way of finding what that remainder is. So let's say I were to take this guy and divide by this one. What I can do is I can just take and plug in x equals 3 into this equation, and when I do that, it should end up being negative 8. So like here, it says f of negative 3. That means you're plugging, or excuse me, f of positive 3, which means you're plugging positive 3 into this equation. That answer should come out to be negative 8. We're replacing x with 3. So when I do that, they've done the computation here for you, and negative 8 is the answer. Now, the reason why that's so important is in like a test or a quiz or even on your homework assignment, if you do the long division or the synthetic division and you want to check your answer, what you can do is just take that 3 and plug it back into the equation, and you should end up getting the remainder that you got for your long and synthetic division. You should end up getting that number. If you don't, then you probably did something wrong on your long division or your synthetic division, okay? So this number should match up with your remainder that you get, okay? So let's go ahead and do an example of that down below here. It says, let me do the star, star, star. Notice that the value of f of 3 is the same as the remainder when the polynomial is divided by x minus 3. This illustrates the remainder theorem, okay? And then down here it's called synthetic substitution. When you're substituting that 3 in, that's called synthetic substitution. It's a convenient way to find the value of a function, especially when the degree of the polynomial is greater than 2. Okay, whatever that is. Synthetic substitution is plugging that 3 in, all right? So let's go ahead and do the synthetic substitution here. And I forgot to write out the entire example. So what we've got going on here is, let's see, this is 2x squared. Okay, so this is 3x to the 4th power minus 2x cubed plus 0x squared plus 5x plus 2. And we're dividing that by x minus 4. Okay, this is the original problem. For some reason I didn't write that down. I don't know why. So this is what we're trying to do down here. Okay, so synthetic substitution. All right, let's go ahead and rather than doing the synthetic division first, let's go ahead over here and let's just plug 4 in. Okay, because we're dividing by x minus 4, so I actually want to plug a positive 4 in. So I'm going to plug a positive 4 into this equation. I've got 3 times 4 to the 4th power minus 2 times 4 to the 3rd power plus 0 times 4 squared, and I'm going to move over for you, plus 5 times 4 plus 2. Okay, so let me grab my calculator if I can find where it's at. Maybe not. Okay, plugging into my calculator. 4 to the 4th minus 2 times 4 to the 3rd plus 0. I really don't have to type the plus 0 times 4 to the 2nd power in because that's going to end up being 0 anyway, but whatever. We'll type it in. Okay, so I end up with, holy cow, 662. I hope I did that right. 662. Okay, so what that means is when I do the synthetic division over here, my remainder should be 662. Okay. That's a way of checking that. So let's go ahead and do this and see what we get. So we're going to drop that first number down, and that is a 3. Okay, 4 times 3 is 12. Okay, and I don't have to flip the symbols. Negative 2 and 12 give me 10, and 4 times 10 is 40. 0 and 40 give me 40, and 4 times 40 is 160. Holy cow. Jeez. 5 and 160 is 165. If I multiply 165 times 4, 165 times 4, that is 660. And if I add that, that's 662. And look at that there. Those two things match up with each other. Okay. So sometimes if you don't want to have to do the synthetic division, you can do that direct substitution, and this won't give you the entire answer of what you get when you divide by x minus 4, but it's a way of checking to make sure that you did that correct. Okay. All right. Next page. They have a story problem here for us. So the number of college students from the United States who study abroad. Studying abroad is like going over. I went over to England for 2 weeks and student taught when I was a senior in college. Most of the time it's for an entire semester, but studying abroad, I mean, you can do that. You can go to different countries, wherever you want to go to. Okay, can be modeled by the function, this whole big, long, ugly thing, yuck. Okay, where x is the number of years since 1930. X equals year since 1930? 1993. Blah. 1993. So x equals 1 would be like 1994. X equals 2 would be like 1995, and so on and so forth. Okay, that's what that's saying. And S of x is the number of students in thousands. Okay, how many U.S. college students will study abroad in 2018? Okay. So they went ahead and they gave us this answer here, x equals 25, okay? If we subtract 2018, or subtract 1993 from 2018, it's actually 25. So x would be 25, and that's what we're going to plug into this equation. So if you want to write it all out, you can. I'm going to, so it makes it easier to plug into my calculator. 0.52 times 25 to the third plus 4.03 times 25 to the second power. Sorry about the child crying in the background. My husband's not doing a very good job of keeping her pacified right now. But we're almost done. All right, so entering that into my calculator. Here we go. Okay, you might want to try practicing this, as always, because it's just good to make sure that you're doing this right. To the fourth power minus 0.52 times 25 to the third power plus 4.03 times to the second power plus 0.09 times 25 plus 77.54. Okay, is 2286.04. Okay, now remember that that number is the number of students in thousands, so it's actually 2,286,000, which means that if we want to write that out correctly, we can move the decimal 3 places, because that would be thousands, and it's actually going to be 2,286,040 students are going to study abroad from the 2 million students study abroad in 2018. That's crazy. That's this year. Woohoo! 2 million students. That's not going to be any of you, sorry. All right, the last one. I'm going to skip this key concept, and I'm going to do this example, and then we'll come back to that, and I'll show you what that means. It says, determine whether x minus 5 is a factor of this thing. Then find all the remaining factors, okay? So what I want to do is I want to find whether this guy goes into there completely. And I'm going to use that synthetic substitution like we did before. So if I set x minus 5 equal to 0, x is equal to 5, and this is the number that I'm going to plug into that equation. So let's do that. 5 cubed minus 7 times 5 squared plus 7 times 5 plus 15. Okay, I'm going to plug that into my calculator and see what we get. So 5 to the third power minus 7 times 5 squared plus 7 times 5 plus 15. I'll do minus later. Okay, and it's 0. Okay, so what that means is that if I would take this guy and divide by x minus 5, I would get a remainder of 0. And when I get remainder of 0, then that means x minus 5 does go into that perfectly, right? If I have a remainder of 0, he goes in there evenly, right? So what this key concept is saying is that x minus r, or x minus 5, whatever x minus that is a factor of our polynomial if the remainder, or if when you plug it in, the answer is 0. So here he is a factor because my remainder is 0. Now they want us to find the remaining factors of the polynomial. So what I'm going to do is I'm going to go ahead and do that synthetic division. I'm going to put 5 on the outside. This is good practice for us to do again. 5 on the outside, and then I look at my coefficients out in front here. This x cubed doesn't have a number in front of it, so it's 1. So I've got 1. Then the next number is negative 7. The next number is a positive 7. And then I've got 15. Okay? So let's go ahead and do this division, or yeah, synthetic division here. I'm going to drop my 1 down. 5 times 1 is 5. And then I add, and that gives me negative 2. And 5 and negative 2 make negative 10 when I multiply, and then I add. So that's negative 3. And 5 and negative 3 is negative 15. And when I add that, that's 0. Ah, look, it matches up again. That last number and my number I get when I plugged in match up, as they should. Okay? So this guy right here, 1, negative 2, and negative 3, if I put the x's back in there, I told you guys before that if I'm starting with x cubed, this number down here should be 1 less than that, okay? So this should be 1x squared minus 2, this should be x, and then minus 3. So I've got x squared minus 2x minus 3, okay? Well, they want us to continue breaking this down, then find the remaining factors of the polynomial. So once I get it to this point, This is a simple trinomial. Simple trinomial, okay? So all I need to ask is what can I multiply together to give me negative 3, but when I add them, give me negative 2, okay? And that is going to be negative 3 and positive 1, okay? Because negative 3 times positive 1 is negative 3, and negative 3 plus 1 is negative 2, okay? So these two are my remaining factors. Also, x minus 5 is a factor. So if I would multiply those three together, I should get this guy here. So rather than multiplying those together like we did in the last section that I taught you, to get this, we're taking this guy and we're breaking it down to get these three pieces. So this is my answer that I want here. That's all three pieces broken down, and that is the end of the section. There you go.